Hello friends, in my this video I am going to discuss another interesting linked list related problem from LeetCode. Okay, and the problem is, given a linked list, remove the nth node from the end of the list and return its head. Okay, so for example, suppose the given linked list is 1, 2, 3, 4, 5. The arrow indicates that is if 1 is the element corresponding to the first node of that linked list, then it will the next reference will indicate to the next node which has the value 2. Like that it is going, and it is singly linked list. From the arrow itself it is quite clear. And n equal to 2, this is also input will be passed, this input also will be passed through our function. And see, from the end side, second node we have to remove. So 1 2 3 4 5, if you go from the end, this is the first and this is the second, so 4 has to be removed. The node which contains the value 4 has to be removed, and after removing the second node from the end, the linked list output should be given as 1 2 3 5. Okay, but we need to return only the head, not the data or not the values which is stored in the node. All right, now pause my video, try to think about one algorithm which can be computed in O of n, big O of n time complexity, and how you can just write in Eclipse or NetBeans or in LeetCode. You just try and then again check my video. If your code runs, then well and good, no need to check mine solution, because if your code is working perfectly, then no need to check, because there are multiple solutions for solving a particular problem. Okay, here I am discussing one of the possible solution which I have done according to the concept which I discussed in my previous video, that how to delete a linked list, a node of a linked list in the easiest way. Okay, so what I will do, I am going to follow the same concept as I mentioned in my previous video. That that previous video link I am going to post in the description. If you want, you can check there. What I generally do in the deleting case, like the general way we follow is we have to check whether that particular node which we are going to delete is in the beginning or in the end or in the middle of the linked list, and according to that different actions has to be taken. Here I have shown you that one algorithm which no need to check this kind of things, simply it can compute. So what is the way? Very simple. First, traverse through the linked list from the beginning to the end and store all the data elements in one array list. Then process the array list according to the given question. Like here, remove the second node, so we will remove the second element from the last in that array list. Okay, and then you make head equal to null. Okay, so as a result, what will happen? The previous linked list which is passed through the function, okay, that will be basically completely deleted. Okay, and you are starting from beginning. Now what you will do, you will add data elements and nodes in that head. Okay, so two ways we can add. One is from the beginning, that is in the front side we can add, or in the end side we can add. But if you know the basics of linked list, then you might know that if we want to add a particular node at the end of the linked list, then we have to use one while loop. So no need to waste that. What we will do, we will add a node in the beginning, because to add node in the beginning of the linked list or in the front side, there is no requirement of any for loop, right, or any while loop. So as no loop is required, so we are going to follow that. But before adding, see, if you want to add in the reverse direction, that is in the front side, if you want to add, then first 5 has to be inserted, then 3, then 2, then 1. So in the reverse way we are going now. So first, in the processed array, you have to reverse that using collection dot reverse, and then you can proceed using normal way. Okay, and I have given the code. It will be much easier if you understand the code. See, class solution. Okay, my class name is solution, and then public list node remove nth from end. This is our function name, and the return type of this function is list node. So we have to return the head pointer. See here it is clearly written, return its head. Okay, and list node head and int, and these two we are passing through our function. Okay, then we are taking the head in another node which is defined as p. Okay, because for traversing no need to use the head pointer, because once you lost your head pointer of the linked list, then you cannot do other processing in the linked list. So better to store the head in some other node. Okay, so list node p equal to head. Then I have created one array list to store all the data elements or values which are present in the node. So array list integer a equal to new array list integer. Then while p not equal to null, we will traverse in the linked list from the beginning to the end, and you know that linked list ends with null. So while p not equal to null, that means we are traversing a dot add p dot val. So we are adding the p dot val, that is value part of the node p in that array list A which we created here, and then we are going to the next node, p equal to p dot next. Simple, right? Then head equal to null, we are deleting the whole linked list. Then see here it is given remove the nth node from the end. If you observe this particular example 1, 2, 3, 4, 5, then from the end side this 4 has to be deleted, right? What is the index position of 4? See, from the beginning it is 0, then 1, then 2, then 3. So third index this is, and the total linked list length is 5, n equal to 2. So 3 is nothing but 5 minus 2. Similarly, that means the if you want to delete one particular element, then you can simply do what? Array length, that is linked list length or array list length minus the number which you have to delete. That's what I have done here. A dot remove a dot size minus n. Okay. So as a result, what will happen in the array list? The data element which is at nth position from the end of the linked list will be deleted. Okay. In collections dot reverse a, because I told you I am going to in the front side of the linked list. Okay, now I am creating the linked list from the beginning. So int l equal to a dot size, int temp equal to 0. While temp less than l, that means while temp less than l, we have to add each and every time we have to add one node in the beginning, so that I am creating one object in the node list node class. See, list node class already defined here. You can see public class list node int val list node next, list node int x equal to val x. This is basically our this particular list node int x is nothing but constructor of this particular class. Okay, so basically I am creating the object ramu. Okay, list node ramu equal to new list node a dot get temp plus plus. I am passing the particular data element taken from the array list, and ramu dot next equal to head, because the new node which is created in the beginning, that will be placed in the head, and head will indicate at the ramu. So head equal to ramu, return head. That's all. So you can submit the code and you can check some statistics. Okay, already I have previously I have run once, so that it is showing a few seconds ago 1 millisecond, but again I am showing you. If you understand the algorithm, you can implement the same program in your favorable language, whether that may be C++, Java, Python, anything. Okay, so basically see here, you can see that the code is successfully run. Okay, run time is 1 millisecond, so sufficiently good only. The time complexity, it will not give time complexity error, because we have not used loop inside loop, nested loop we have not used in our code. We have used one while loop here and another while loop here, so basically two separate while loops. So worst case time complexity will be linear only, O of n. Okay, but it will be space complexity you will get. But generally space complexity is never a point of discussion in the competitive programming. Always they check the time complexity, because we have no deficiency of space, but we have deficiency of time, right? So I hope you have understood this. This is all for my this video. I am going to post the same code in the comment section. If you want, you can check there. And for the detailed explanation how to remove a node from a linked list in any position in the easiest way, to know that, please check the description given in the please check the description box. I will post the link. Okay, thank you for watching.